Hey guys, today we will learn about the best location for bar compensation for a transmission line. You know what I mean? Uh, and I was kind of busy because this week I'm gonna graduate. Yeah, yeah, and bar compensation is like a SPC or capacitor bank or FACT, device like that. So we will do a quick review, a little bit. So this is a power line, and then this is we say sending VS, and here is receiving VR, right? You guys remember? And then first for this, the magnitude, you know, not degree. This part is related reactive power. And then this angle, theta, I mean, angle is related active power, right? So the power flows from the big magnitude and then to lower magnitude. Like for example, if it's like 10, and second is 99, 90, and then 0. So this is more big number, right? So reactive powers from here to here, and also the angle is here is more bigger, right? So also active power is from to here. You know what I mean? Like here. Yeah, this is a quite deep review, and then this is here. We have conjugation, right? This is because our general system is lagging current because we use lots of motors. That's why we use conjugations. We wrote down the conjugation on the current. You guys remember, right? And then here is this is P related sine theta, and this is Q, right? Cosine theta. So the best location, for the bar compensation is actually the bidder side. You know what I mean? The bidder side is the best location. Well, we will see. Okay. Okay. First of all, we need to. This is the same. Okay. So here is a V sender, right? Sending, and this is VR. Oh, here, sorry. And I will say between them, the angle is delta, right? So I will say here is 2 delta, and here is minus 2 delta. So the total is delta, right? So our question was best location for bar compensation, right? So we need to put the exactly the middle point. I will say this is VM. Yeah, VM. So what I mean is, so look at that. First of all, there's a now just we put it here, right? So look at that. This is delta, but this is I divided here and here, right? So since we, our main purpose is since we put the bar compensation, what's the happening? The result is we reduce the line current, right? So our main purpose is we need to reduce the line current because there's R and JEX. If we didn't put the, here's a for capacitor bank or whatever thing, yeah, a bar compensation, which means this current is really big because it includes the reactive powers current, right? But since we added, like for example, capacitor bank, what happened? We reduced here. DC current signs, signs current. We only wanna send the what is it, cosine, active current, right? So that's why we reduce the line current line current loss, power loss, because I R plus JX is line loss, right? But since we added this C, we by the way, we reduce this line loss, right? So we wanna make it VS almost, equal to VR, which means good, good thing, yeah, there's no loss, right? So yeah, that's what I wanted to say. So first of all, we put here this middle side, right? So if we, as you know, we already try to find out the equation, how we find out P and Q, right? So now I will focusing on P first. So which means here's V, it's the same, right? So depending on the delta, this is P. But what I mean is, since we add the bar compensation here, so which means we wanna first make it VS and the VM and VR. We wanna just make it same values, right? And then what happened? So which means now they are different values, right? At first, we didn't, connect it bar compensation. It doesn't work. Just connect it. But since we are operating this, what happened here? So VM is it gotta be make it more increased the values, right? So that's why it make it this, try to make it these same values. So what happened is, if we added this VM here, the VM point, the bar compensation, what happened is the P is gotta be changed to this. You know what I mean? The result is. So what I mean is, look at that. So first of all, I will explain. So our first of all, P sending is this one, right? But look at that. If we divide it to here, it's actually the middle point, right? So now the x is 2x, right? And v is here, v is 2, because we have all the same values, right? So 2v, yeah. And then, no, sorry, v. And then we have here sine. But what I mean is sine is delta is here, half, right? 2 delta is half. And then we have one more, same, right? So x is 2x, and then v is the same, right? They are same. So sine 2 delta over 2. If we, add this, it got up this. So what happened? The result is here. The P's voltage is double, and the angle is half. So let's see. Just if we see this number, we don't know what's going on. Let's see here, the next page. So you guys already we already learned about the generator, curve, right? So quickly, yeah. Here's a steady state, I mean stability limit. We can now over 90 degrees at first time, right? So for our so what I mean is our general, the operating angle is between 20 to 30 degrees here at this point. But since we added the bar compensation, what happened? The angle is gonna be double, right? Actually, it cannot over the 90, because if it's over, it's gotta be a break. You know what I mean? So that's why we don't wanna make any of list, you know what I mean, around here. We don't want operating because once it's over, it's gonna be broken, the generator, right? So, but just since we added the bar compensation, just the middle point, VM point, right? So what happened is, look at that. The angle point is here. Once 90 degrees here. Just I will edit since we added the bar compensation. What happened? At first time, it was here, right? 90 degrees, it cannot over. And then around this is 30 degree, for example. So we operating here, this point to here, this 20 to 30 degree here. But since we have here 180, now we could add it to here, right? So it's still 90, right? But even though we cannot over the 90, but what happened? We could operating here, this point, compared to here and this point. Different, right? The stability is increased, you know what I mean? And then the P's, you know, flowing, sending the P power is more increased, double times increased, right? But since if we say like, oh, it's a really good thing, yeah, to install the power compensation on the just a middle point. But there's also pros and cons. Pros part is, as I said, the angles gotta be increased. The stability is more stable. You know what I mean? Since we could add more angle, and then we could send more powers, active power here means. But look at that. What happened is here, it's the same, right? About the Q, Q is reactive power, right? So here's also 2 and then minus 2 to delta, and between them is delta. So what happened is about the Q, and then from here we need to send it to this line, and then number 1 side and then number 2 side. You need to supply, right? Q when it comes to Q, right? But the result is so now it's Vs equal Vm and equal Vr. We say just the V, right? So we could calculate these numbers, and so the total is Q is we need to both times more of Qs compared to, you know, compared to previously we didn't install the bar compensation. Except that, but we still, you know, could since we installed the free bar compensation, we could, you know, send the more active powers, and we could get the more increased the stability, stability. You know what I mean? We increased. What about the generators? You know, curve as we can see before. But the negative part is here. We need to more generate the Q, reactive powers, and we need to send them more, most of them, right? Yeah, today's lecture is, yeah, this is done. If you guys have any questions, let me know. Yeah, thanks.